Hello student, and today's class few questions from determinant using properties of determinant. Now what is the question? 1x x square 1x x square 1 is equal to 1 minus x cube the whole square. So this also is a nice question from inside the book. So let us start with the assumption. The given determinant is taken as delta 1x x square 1x x square 1. Okay, adding r1 r2 and r3 we can get 1 plus x square, or adding c1 c2 c3 also we can get similar term 1 plus x square. So we can do for r1 is r1 plus r2 plus r3, then delta equal to 1 plus x square 1 plus x square 1 plus x square, then x square 1 x square 1. From r1 1 plus x square is a common factor, so taking out 1 plus x square from r1, and delta is written as a multiple of the common factor 1 plus x square times the determinant 1 x square 1x and x square 1. So we got first row as unit row 1 1 1. As we discussed earlier, out of 3 ones we can convert any 2 1 0. The 1 from C2 and 1 from C3 can be converted into 0. Applying the property C2 is C2 minus C1 and C3 is C3 minus C1. Then delta, so 1 plus x square time, no change in C1 1 x square x, and C2 1 minus 1 0, 1 minus x square minus x, again 0, x minus x square and 1 minus x. From C2 we can take 1 minus x as common factor. From C3 also 1 minus x common factor. So taking out 1 minus x from C2 and C3, then delta is now 1 minus x the whole square into 1 plus x square. Then 1 0 0 x square x. So 1 minus x square is 1 minus x into 1 plus x. 1 minus x is taken as common factor, the remaining factor 1 plus x, and this is minus x into x minus 1. Or minus x into 1 minus x, correct? Minus x into 1 minus x into minus x plus x square. So we have taken 1 minus x common factor, means remaining factor minus x, and there also, and x into 1 minus x, so x remaining, then 1 minus x, there is 1 remaining. Okay, now we can expand the determinant along CR1 because there are 2 zeros. Expanding along R1, delta is 1 minus x the whole square into 1 plus x square into A11. A11 is a cross multiplication of these 4 terms, 1 plus x into 1 minus of minus plus x square. So the delta is a given determinant 1x x square 1x x square 1. So 1 minus x into 1 plus x square, 1 minus x into 1 plus x square, the whole square. From using identity a minus b into a square plus ab plus b square, the same way 1 minus x into 1 plus x square, a cube minus b cube, that is 1 cube, 1 minus x cube. So this is 1 minus x cube the whole square, hence the proof. We will go to the next question. So we will continue next question. The determinant with the first row a, b, c, second row a minus b, b minus c, c minus a, third row b plus c plus a plus b is equal to a cube plus b cube plus c cube minus 3abc. So a delta equal to a, b, c, a minus b, b minus c, c minus a, b plus c, c plus a plus b. So my dear student, we should remember a cube plus b cube plus c cube minus 3abc. This is nothing but from 9th standard identity a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Okay. So the product of these two factors a plus b plus c and a square plus b square plus c square minus ab minus bc minus ca is nothing but if you multiply you can get a cube plus b cube plus c cube minus 3abc. So what is the indication? So one of the factor of the required expression a plus b plus c, we can try for this. Adding r1 and r3 we can get a plus b plus c. So we can write r3 as r3 plus r1. Then delta equal to a, b, c, a minus b, b minus c, c minus a. Adding these two, a plus b plus c, a plus b plus c, a plus b plus c. Okay. Then a plus b plus c is a common factor from R3. So taking out the common factor from the determinant, from particularly third row, a plus b plus c time a, b, c, a minus b, b minus c, c minus a, 1, 1, 1. So whenever we come across a unit row or unit column, we have to convert any two unit terms into 0. We can try to convert these two one into 0. But the right formula for C2 is C2 minus C1 and C3 is C3 minus C1. Then delta equal to a plus b plus c time and a minus b 1 and b minus a, this minus this, here a minus b, b minus c, c minus a, there is no common term. So b minus a, b minus b, 2b, and minus c, minus c, minus c, minus c. Difference of these two, b minus b, 2b, minus c and minus a. C minus b, then c minus c, 2c, minus a, minus b, is 0, 0. There are two zeros in R3, so we can expand along R3, expanding along R3, delta equal to a plus b plus c, cross multiplication of these four elements. So this is A1, A31 positive. So cross multiplication taking B into 2C, 2BC and B into A minus AB, B into B minus B square minus 2AC minus into minus plus A square minus into minus plus AB. Okay, we have to subtract every product. 2BC should be subtracted, minus 2BC and minus, so plus 2B square, taking C minus C square, so plus C square, minus or minus plus BC minus BC we have to subtract, then minus AC, now plus AC, then AB plus AB, so subtraction minus AB. Okay, now delta equal to delta is a given determinant A, B, C, A minus B, B minus C, C minus A and B plus C, C plus A plus B is equal to A plus B plus C into A square. There is no cancellation for A square, then 2B square minus B square, 1B square, then plus C square and AB minus AB plus AB cancel, so minus AB minus BC minus AC. As we discussed in the beginning, A plus A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA, and this is nothing but A cube plus B cube plus C cube minus 3ABC. This is equal to A cube plus B cube plus C cube minus 3 times ABC, hence the proof. Okay, go through it. So we'll discuss one more question. The next question, really interesting question. So we have to split into two determinants and then we have to combine, then applying properties, then we can get this result 1 plus P xyz into x minus y minus z minus x. So all these three factor in cyclic order. So the determinant x square 1 plus p x cube, y square 1 plus p y cube, z square 1 plus p z cube is split into two determinants according to a property. So x square, take first term alone 1, y square 1 and z square 1. Here x square p x cube, y square and p y cube, z square p z cube. From delta 2 we can take p is a common factor from C3. So taking out P3 from C3 of delta 2, second determinant, then the delta equal to, this is delta equal to, and x square 1, y square 1, z square 1, taking out p as a common factor, p times x square x cube, y square y cube, z square z cube. Again, so looking at the determinant delta 2, x is a common factor from R1, y is a common factor from R2 and z is a common factor from R3. So once again taking out and x taking out x comma y comma z from R1 comma R2 comma R3 of second determinant delta 2, then delta equal to 1x square and in cyclic order we can write. In real, we write without affecting the cyclic nature, we can write 1x x square, 1y y square, 1z z square, x square y square z square, plus and p x y z, 1x x square, 1y y square, 1z z square. From these two determinants, the two determinant delta 1 and delta 2 part common, so we can factorize as in algebra 1 plus p x y z time the determinant 1 x x square, 1 y y square, 1 z z square. Now we have got a unit column, so better convert 2 unit into 0 using properties on R2 as well as R3. Now we can write R2 is R2 minus R1 and R3 is R3 minus R1. Now delta equal to 1 plus p x y z into no change in R1, 1x x square, 1x x square. Then 1 minus 1, 0, reverse order, y minus x and y square minus x square. And again 0, z minus x, z square minus x square. From the determinant, from R2, we can take y minus x, z minus x from R3 is a common factor, so delta equal to y minus x, one more factor, z minus x into 1 plus p x y z into 1 x x square, 0, y minus x taken 1, y plus x and 0, z minus x common factors taking out, so z plus x. Let us expand the determinant along C1. Expanding along first column C1. Then delta equal to y minus x, z minus x into 1 plus p x y z into A11 cross product of these 4 elements, z plus x minus y minus x. So minus x and plus x cancel. So z minus y, y minus x, z minus x. So this is already in cyclic order. So writing in cyclic order, the determinant x square 1 plus p x cube, y square 1 plus p y cube, z square 1 plus p z cube is equal to 1 plus p x y z into x minus y, y minus z into z minus x. This is the required result, hence the proof. So dear students, we will meet in the next video class. Please convey this to your friends and like these videos to appreciate me, and so that I can put more and more videos for the benefit of students. Thank you.